The moon, our closest neighbor, may appear to be Earth's younger sibling. Since its inception, the satellite has mostly sat there, playing gravitational tug-of-war. But what if the moon disappeared tomorrow? A lot of things would have changed pretty dramatically 3 billion years ago when the moon was closer to Earth, says Matthew Siegler, a lunar research scientist at the Planetary Science Institute in Dallas, Texas. Right now, the moon is far enough away that the majority of what it does for us is long-term, such as stabilizing our orbit over hundreds of thousands of years. The moon is more than a pretty face to look at night. It influences the movement of the Earth's atmosphere and climate, as well as the tilt of our planet's axis. So, what would happen to Earth and us if it vanished without a trace? Would we survive it? Unfortunately, not. We would immediately notice that nighttime would be significantly darker. The surface of the moon reflects sunlight, brightening our night sky. Without that indirect glow, any areas without access to artificial light, such as country roads or wooden campsites, would be far more dangerous to travel through at night. Animals would be confused if the moon suddenly disappeared. The presence of the moon benefits animals that use vision as their primary mode of interaction with the world, according to researchers. That comes as no surprise, but it has intriguing implications for the question at hand. Many predators such as owls and lions hunt under the cover of darkness with only a sliver of moonlight. They would have difficulty finding food if there was no moon. Rodents, on the other hand, prefer to hide when the moonlight is bright. Their predators can detect them more easily. They would thrive in the absence of the moon. I believe you'd see some shifts in which species are common and which are rare in a system, says the study's lead author, Laura Prue, a wildlife ecologist at the University of Washington. The tides are the next obvious difference. Because the moon is so close to us, its gravitational pull has an effect on our planet. That force is powerful enough to pull our oceans back and forth, which we refer to as the tides. According to Matt Siegler, a research scientist at NASA's Jet Propulsion Laboratory who works on the Lunar Reconnaissance Orbiter, without the moon, tides would rise and fall at a much slower rate, about 1/3 of their current fluctuation. The tides would continue to move because the sun has some gravitational pull on the oceans, though not nearly as much as the moon. A 2/3 reduction in tides would have significant impact on coastal ecosystems, potentially destroying many and disrupting the flow of energy, water, minerals, and other resources. In the ocean areas between high and low tides, entire ecosystems exist. Many crabs, snails, barnacles, mussels, sea stars, kelp, and algae rely on the daily coming and going of the tide to survive in these areas. These ecosystems, in turn, provide food for migrating and local birds, as well as land mammals such as bears, raccoons, and deer. Tidal movements also influence ocean currents, which in turn influence global weather patterns by disrupting warm weather and precipitation around the world. Without them, regional temperatures and major weather events would be much more extreme. According to Jack Burns, director of the University of Colorado, Boulder's Network for Exploration and Space Science. And it's not just the tides, he claims. The moon's gravitational pull moves molecules in the atmosphere in a similar way. Large moons are one of the main things researchers look for when identifying planets that could host life because of this climate-stabilizing force, according to Burns. A planet outside of our solar system needs a fairly large moon for the weather systems to be calm enough to produce civilization like ours, Burns says. Researchers have argued that without this celestial body, life as we know it might not exist at all. A missing moon could cause even more upheaval, albeit on a much longer timescale. The tilt of our home planet's axis would most likely shift dramatically over time if the moon's gravity did not hold it in place. In a few 100,000 years, the Earth could go from having no tilt and almost no seasons to having a drastic tilt with extreme seasonal weather changes and ice ages, according to Siegler. He uses Mars as an example, with its extreme climate variations caused by dramatic changes in the tilt of its axis. It is not stopped by a large, stabilizing moon. Our 24-hour days are also partly due to the moon. Without the moon, a day on Earth would only last 6 to 12 hours, writes Inside Science. There could be over 1,000 days in a year. That's because the Earth's rotation slows over time due to gravitational force, or the moon's pull, and without it, days would pass in a flash. You're probably aware that a massive asteroid colliding with Earth 66 million years ago was responsible for the extinction of the dinosaurs and much other life on our planet. What you may not realize is that the moon could serve as our first line of defense against other objects hurtling through space. Without the moon stopping some asteroids that might otherwise make their way down here, Banakar speculates, we'd be in the line of fire. On a more personal level, without the moon, we'd be without a source of inspiration and scientific data. We were very fortunate to have the moon as an easy destination to pursue. Siegler says it inspires us. He emphasized how much the moon has taught us about the origins of our planet, how other planets form, and how dinosaurs became extinct. We'd be missing out on a lot of information, he says. Fortunately, there is no indication that the moon will self-destruct or collide with another orbiter anytime soon. So that's the end of the video. Make sure to like the video, subscribe to our YouTube channel, and press the notification bell so you never miss out on our next videos. Until the next video, take care.